All right, so today we're going to be just doing an introduction of inverses, okay? So we've learned about it in the past, right? Inverses is very important in math because it helps you kind of undo something, right? Okay, so whenever you want to undo something or to become 1, you multiply whatever you're trying to undo by the inverse. Like when we look at this first one here, this 2 times 1/2, what does that give me? Well, that gives me 2 over 2, which then equals 1. Same thing can be said about this. 3 times 1/3 equals 1. It's just 3 over 3. And then 25 times 1/25 equals 25 over 25, which then just equals 1. So when you multiply matrix inverses together, you get the identity. I don't know why I capitalized the I, sorry. You get the identity matrix. Okay, you get the identity matrix. What does that look like? Well, a singular matrix like this is 1, right? So when we just have a 1, this would be a 1 by 1, right? Our 2 by 2. See, our identity matrix is always going to be a square matrix. So here's what our 2 by 2 would look like. Okay, our 3 by 3 would look like this. 1, 0, 0, 1, 0, 0, 0, 1. It's just your first diagonal is always going to be 1s, okay? And then a 4 by 4. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 0, 1. There you go. So that's what our identity matrix is like. So that's the goal today, right? So if we want to know whether two matrices are inverse to each other, we're going to multiply them together, okay? And we should get the identity matrix if they are, okay? So what else is special about the identity matrix? Well, I just said it helps us to determine if two matrices are inverses of each other. So let's go ahead and let's look at this example here, okay? So if I multiply any matrix by any matrix, is like multiplying a number by 1. So when I multiply these together, I should get this same matrix here. So let's go ahead and let's do that. So we've got a 2 by 2 times a 2 by 2, right? So I'm going to go ahead, and since we know our outsides, yes, we have a 2 by 2. So how do we come up with our solution matrix? We take our outsides, so the rows of our first one, columns of our second, bring those together so we know we're going to have a 2 by 2 here. Okay, so again, I'm using my 2 colors here. I'm labeling the rows in the first matrix. So that's all I care about in the first matrix. All I care about is the columns in the second matrix. Okay, so here we go now. So we're going to take, and then once you do that, then you label it to your solution matrix. So row 1, row 2, column 1, column 2, and here we go. Okay, so we're taking row 1 times column 1 for right here. So row 1, so 1 times 6 is 6. 0 times 1 is 0, and so we just have 6. Okay, now we're going row 1, column 2. So 1 times negative 2, leave it at the negative 2. 0 times negative 1 is 0. Now we're looking at row 2, column 1 for this spot, row 2. So 0 times 6 is 0. 1 times 1 is 1. And then row 2 times column 2 for this last spot here. So row 2, so 0 times negative 2, which is 0. 1 times negative 1, it's negative 1. And look what happened there, right? Did I not just say, I just said this, right? Like, we're getting the exact same matrices. That's the same thing as like multiplying anything by 1. You multiply 100 by 1, what are you going to get? You're going to get 100. If you multiply 15 by 1, what are you going to get? You're going to get 15. If you multiply negative 20 by 1, what are you going to get? You're going to get a negative 20. Okay? So, verifying inverses. If A times B equals I, and I, that's, whenever you see a big capital I like that, that means identity matrix, and B times A equals I, then the matrix A and B are inverses. Okay? So tonight on the homework, okay, you don't need an example here because we just did multiplication yesterday, okay? You just need to understand on the homework tonight, you have to do A times B and then B times A. If you get the identity matrix, and since we're only working with 2 by 2 matrices on the homework tonight, this is what you should be looking for. If you get this after doing A times B and B times A, then they are inverses of each other. If one of them yields it, but the other doesn't, then they're not inverses of each other. If you're doing the first one and it doesn't yield this whatsoever, you're done. There's no way they're inverses of each other. Both A and B, A times B and B times A have to equal the identity matrix. Okay? All right. So that is it for today. Okay, like I said, pretty short lesson. Okay, and I will talk to you guys. I'll see you guys on Thursday. Thank you. Bye.